Hello, everybody, and welcome to this section of the lecture where I talk about the 4 reasons why everyone should study geology. But before I get into those reasons, let me just say that geology is probably the most practical subject that you could study. And the reason for that is because we're surrounded by it. It dominates our lives. Whether we think about it or not, it does. Just think about where you like to vacation. Is it the beach, the mountains, the desert? Maybe you like to visit glaciers. Maybe you have been to Alaska and you've seen the glaciers. One of the big grabs for Alaska is that there are still glaciers there. So everybody wants to see them before they're all gone. It might be a city, it might be a country town, but they are all what they are because of geology. So, why is it important? Well, geology is what supplies the things that society needs. All of these things that are listed, yes, we need them, along with so many more things that you've probably never heard of. We need those things for our computers, our phones, our iPads, our iPods. But most people, I find, are really oblivious to the role that geology plays in all these things. Let's take something as simple as a pencil. I'm holding up a pencil right now. A pencil is pretty simple, right? Very inexpensive. Well, what sorts of geological materials go into that pencil? Well, first of all, we have the pencil lead, which really isn't lead, it's graphite, and that graphite has to be mined. Then after it's mined, of course, it has to go to be processed to become just the graphite, because when graphite is mined, it's going to have a rock matrix in it, so it has to be refined into just the graphite. But it also, depending on what the use is for the pencil, that graphite has to be changed in some way. We think about a number 1 pencil, number 2 pencil, number 3 pencil. There are pencils for all kinds of needs out there. So we have to have a particular hardness, or conversely, softness to the pencil. And clay is added. So clay is a geologic material. Then the eraser. Well, the eraser used to be composed of natural rubber from trees, but now erasers are made from petroleum products. And sometimes pumice, which is a geologic material, a volcanic rock, is added. And what about the paint on the pencil? Sometimes it's shiny and kind of sparkly. The first thing we need to make sure of is that it's not toxic, because a lot of people like to bite pencils, so we don't want to kill those people. But sometimes it's shiny, and in order to make it shiny, we have certain geological materials that are added to the paint itself. And let's not forget the aluminum at the end of the pencil before the eraser. Aluminum is a metal, and it has to be mined. And of course, smelted. That's just a pencil. What about everything else? The materials in our cars, our homes, computers, and on and on and on. Just go to your bathroom. Look at the bathroom fixtures. Look at the tile on your floor or on your walls. All of that is geologic material. Now, yes, some of it is man-made, but, things like marble and slate, porcelain, those are geologic materials. Everything we use, everything we need is made of stuff that has to be either mined or grown, and that's it. There are only 2 sources for it all. So think about that. Then the other reason that everybody should study geology is to avoid geologic hazards and to know something about them. In order to avoid them, you have to know something about them. Earthquakes, landslides, volcanoes, floods, and the list goes on. In California, we have all these and more. And if you're keeping up with the news, you know that Tonga is impacted because one of their sister islands, the volcano blew up and caused a tsunami that killed some people. Thankfully, not a whole lot of people were killed. But if you want to understand why these things happen, why does a volcano erupt? Why are there earthquakes? If you want to know why this stuff happens, then you have to take geology. Also, if you are, in the market for a place to live, maybe you want to buy a house. Well, it would behoove you to know whether that house is in a floodplain, what kind of fault lines are nearby, is it a landslide prone area? All these things are important to know. Then, to understand how to protect our environment, geologists are involved in this. Ground and surface water protection. If you have to drill a well, is that water going to be good to drink? Is it going to be, how deep will you have to go to get it? And now we have to go deeper and deeper to get it. Slope stabilization from areas that have been mined or areas that have been disturbed in some way, like highway construction. Land reclamation, land being reclaimed for various reasons or another. Maybe we're reclaiming or we're reconstructing swamps or marshland after some type of construction or some type of issue. And then, of course, all kinds of other issues, especially the ones that are related to climate change, with sea level rise being a major one. What else? To better appreciate your surroundings. Maybe you don't pay too much attention to the previous three, but everybody is in awe of certain things. I can't think that anybody would go to Yosemite and not wonder how the heck that stuff got there. All that granite in all its majesty, who would not look at it and want to know why, how? Same thing with Grand Canyon. Same thing with San Francisco. San Francisco, famous for its hills, the bay, the ocean beside it. Why is it there? Geology. Plate tectonics is why it's there. So, let's look at some examples of all this. Here we go. This is an oil drilling platform out in the Gulf of Mexico. And if you've ever looked at Google Earth and maybe you thought to yourself, hey, I'd like to see where all the oil drilling platforms are, you will be amazed at the number of them out there. There are hundreds and hundreds. Well, why do we do this? Because we need oil. But we have to understand that, yes, those are there, but sometimes bad things can happen. This is the Deepwater Horizon explosion in 2010. I can't believe it's been that long now, which 11 people were killed. That's one of the things that people forget about this disaster. They always think about the impact that this had on the fishing industries, the shrimping industry, and the marshlands around Louisiana and the Gulf Coast. But 11 people were killed when this happened, and billions of dollars in environmental damage. Then this is an iron mine in Minnesota. Iron is something that we need a lot of. We have to have iron to make steel, and you can see the equipment down there. You can see how extensive this mine is just by looking at how small this equipment looks. And it's not really small, it's huge. This is a coal mine in West Virginia, and this is called mountaintop removal, which mixed feelings about this. These mountains are the oldest mountains in the world, maybe the second oldest mountains in the world. No, I think they're the oldest mountains in the world, Appalachian Mountains. And on all that time that things have had to evolve, like the animals and the plants in this area, it's the most biodiverse region ever. we can come in and in a matter of months, we bring that mountain down. And why? Because we need coal. This is how coal mining is done in West Virginia, Ohio, Kentucky, and portions of Virginia. Luckily, Virginia has just a small 7-county area where there's coal. Well, we need coal. We do. It's dirty. It's the dirtiest of the fossil fuels. But we have to think about the environment, and not only that, but all the toxins associated with coal mining, the coal dust, the contamination of groundwater from it, all of this. Don't want to bring you down, but there is that. This is a copper mine in Utah. This is one of the largest copper mines in the world. This is Bingham Canyon. All of those things that you see there, those terraces, are roads where they just keep continually enlarging this big pit. And those little black features that you see there that look like ants, those are huge pieces of machinery. And then water is a big issue. We know that here in California. If you've ever flown over the country and you've looked down out of the window and you see these crop circles, these round green things, this is from center pivot irrigation. These are crops that are being grown, and there's a well in the middle of all these, and there's an irrigation line that's attached to the well that just goes round and round and round, spraying out water. And that is a very intensive use of groundwater. And as a result, the aquifer there that took tens of thousands of years to be supplied, to be charged up, if you will, now in less than 50 years, that aquifer, it's called the Ogallala Aquifer, is in danger of being depleted. And one of the reasons is because this is a fairly dry land area, not a lot of rain, but they tapped into groundwater to be able to grow all these crops. And this gives you an idea of how it has expanded. These are some pictures from an area in Kansas, I believe, 1972, and you see there were a lot of square fields out there, and that was just dry land farming. But by 2015, the amount of farming that's being done has expanded, and the reason that it has expanded is because of center pivot irrigation. Then natural disasters. We all know about the tsunami in 2011 from the earthquake in Japan. So one of the things I hope you learn in here is if you're ever on the beach and you see water receding from the beach, you're lucky, you have a warning. That just means that the trough of the wave has arrived before the crest of the wave. So all you need to do is turn around and run as fast as you can, don't even think about it, to high ground. And then this is in California. This is in the Malibu area where, you know, beautiful scenery, and we have these beautiful mega mansions, but they are in danger of falling into the ocean because that rock material, not even really any rock material, it's very unconsolidated material, and you've got the ocean that never stops pounding against it. So when those cliffs are undercut, everything can come tumbling down. Here's another example of that. This is Pacifica, south of San Francisco. These apartment buildings, of course, are abandoned now because they started falling into the ocean. And these heavy storms that we get when we have these El Nino years, or these atmospheric rivers that come in, they don't do too much to help the stability of the cliffs. You can see some rock at the bottom of the cliff. That's one of the things that people have done to try to expend the energy of the waves on the rocks rather than the base of the cliff. But that doesn't work very well for very long because the rocks get undercut and they fall down, and then the water is pounding against the cliffs once more. Then what about protecting our environment? Well, that mine site that I showed you in West Virginia a few slides ago, here it is when it's reclaimed. And yes, it looks much better than it did when it was being mined. They've vegetated it, left a few little ponds around, but it's still not like the natural ecosystem. One of the things that a miner has to do, I should say an owner has to do, is submit plans. And they have to plan for post-mining land use. And there's not a lot of flat land in these areas. So one of the things that they do is they say, okay, we're going to put it back to hay and pasture land or some type of industrial use. And people like that because they can build, well, for one of the things that they're building on these flat pieces of land are prisons. And I don't know if that's what people envisioned as new industries coming in when they were told that, yes, if we do this, we'll have lots of jobs. I'm not sure that prison guard was the job that anybody envisioned. And then appreciating the world around us. Well, this is at Point Reyes. One of these days I hope to get back in person because one of the field trips that we did every year was to Point Reyes. And this is one of the longest stretches of beach in California with no development. Beautiful, beautiful area. Anybody can look at that and appreciate it for what it is. And then rocks, of course. As I said in the syllabus, I think road trips will never be the same again. I mean, what could possibly have caused this? This is in Scotland, and these are some of the oldest rocks in the world. This tells us a lot about geologic activity. That is at the surface now, but that did not happen at the surface. That happened underground. Those rocks were underground. The darker rocks were existing, and those lighter colored rocks, that was magma, granitic magma. So that's granitic rock, and at the time it was molten, and it made room for itself in any weak areas or fractures that it saw in the rock. But now it's exposed at the surface, and we can look at it and get an idea of just how crazy the processes are that make this Earth. And then, of course, Niagara Falls. Niagara Falls, one of the scenic wonders of the world, and it's there as a result of harder rock. Rivers will wear down. They erode, they transport, and they deposit. That's their lot in life. So it has eroded as much as it could, but it's having a harder time because it ran into a more resistant layer of rock. But guess what? It will eventually erode those suckers, and there won't be a Niagara Falls there any longer, which is sad. So get there. You have some time. It'll take a while for it to happen.